Okay, here are some examples to help you practice using our new theorems about segments and circles. So I'll refer to them as we go. You might want to have your circle theorem wheel handy so that you can reference it. The first one I'm looking at, and I'm identifying that we have chord theorem because we have two chords intersecting in our circle. So I would be referencing right now theorem number 1015 on your circle wheel. And we're going to go ahead and set this one up. I like to use those shortcuts that I told you about. So the shortcut that I'm going to use right now is what I wrote down on there, P times P equals P times P. Remember, the P stands for parts, because what I know about when I have chords intersecting is I know that the two parts of one chord, so that would be the 3 and the x, when I multiply those, the product is always equal to the product of the two parts of the other chord, which would be the 12 and the 2. So if I do that, I've got 3 times x equals 24, divide by 3, and I've got x equals 8. We can do a quick double check. 3 times 8 for this chord gives me 24. 12 times 2 gives me 24. We're done. Second one. I'm looking at this one, and I'm identifying that we have a secant and a tangent. So I'm referring to the last one that we wrote down, Theorem 1017, on your reference sheet. And our shortcut for this one was W times OP equals T squared. That's my shortcut. W stands for whole. So I'm looking at my secant right now, and I'm looking at that and saying the whole length is 18 plus 6, which is 24. Okay, that was the whole. The outer part is just this part, the 6. So 24 times 6 is equal to, and then I've got the tangent part, because I don't have anything else there, I just multiply it by itself or square it, equals x squared. Okay, notice that we didn't ever use the 18 except to get the 24. Common mistake is we like to multiply 18 times 6 right here instead of 24 times 6. That's what my W stands for, is whole. Now I'm just doing the math. So I've got 24 times 6 does give me 144. It's equal to x squared. Take the square root of both sides. So I'm getting x is equal to 12 for this one. Okay, just an FYI for you, we might end up with a radical answer. If 144 had not been a perfect square, then I would expect your answer in simplest radical form. You guys know how to reduce your radicals. Just use those skills. On to number 3. So the third and last theorem that we haven't used, actually we had 4 of them, but this one is the secant times secant, or secant theorem. So I'm referencing 1016 on your circle wheel, if you want a number. And my shortcut for remembering this one was WOP equals WOP, where W stands for whole, OP stands for outer part. Okay, that's just my reference for remembering this. Let's look at one of our secants. It doesn't matter which one. I'm just going to start with this top one, and it looks like my whole length is 12 for that, times the outer part is my 4. Okay, notice again I didn't use the 8 by itself. I used the whole and the outer part. And then if I go to my other secant, I've got the whole length is not just the x or the 6, it's the combination. So we're going to write that as x plus 6, not 6x. We're going to add them, not multiply. Whole times the outer part is 6. And again, I didn't just use the x by itself. I used the x to give me the whole length when I added 6 to it. Okay, that's your setup. From here, it's just an algebra problem. So let's go ahead and work through the algebra. 48 is equal to x plus 6 times 6. I'm going to go ahead and distribute. So I've got 6x plus 36. Alternatively, you could have divided by 6 on both sides. 48 minus 36 gives me a 12 is equal to 6x for a final answer of, it looks like x is equal to 2. And of course we could double check that, should double check that just by going back to the beginning and saying, okay, 12 times 4, whole times outer part is 48. If this is a 2, I've got 8 times 6 also giving me 48. Okay, there's 2 more questions that are multi-step questions. You can keep following my video. If you want to pause it and try them on your own, that's fine. And then you could check back in and see how you did. So number 4, it looks like I've got 2 secants and a tangent. So possibility of using secant-tangent theorem and also secant-secant theorem. Let's see what we have going on here. So I'm going to do some labeling. ED is 6. So I know that this is 6 right here. CF is 12. And AD is 10. Find AB and AC. AB and AC. Okay, so we could look at, it doesn't matter which one we're looking for. First, I'm going to go ahead and say, let's just look for AB since that's the first one that we're asked for. AB is equal to what? So if I'm looking at AB, it appears that AB is a tangent in this problem. So I've got this tangent and then I need a secant with it. Between my 2 secants, because I've got 2 secants, AF and AE, AF I only know one part for. AE I know both of them. So I'm going to go ahead and simplify my picture to just looking at AB, which I'm going to call X for the time being, and AE up here. And I'm going to be looking at secant tangent, similar to the second one that we did. I'm on theorem 1017, my secant tangent theorem. So here's what my theorem tells me. It tells me that the whole times the outer part is equal to the tangent squared. And my tangent is my unknown. So I've got x squared for my tangent part, and then I need my whole and my outer part. So if I'm looking at AE up here, I've got the whole length is 10 plus 6 or 16. So I've got 16 for that whole times the outer part was the 10 that I had labeled here for AD. So I've got 16 times 10 equal to x squared. Do the math. 160 equals x squared. Here's what I warned you about. You might end up with a radical answer. 160 is not a perfect square. I do know that 160 breaks down to 16 times 10 is what I'm thinking, or maybe you're doing the factor tree right now. 16 is a perfect square, giving me 4. So x is going to be 4 radical 10 for my final answer there for AB. So that's 4 radical 10, first answer. Second answer is I'm trying to find AC. So just for the sake of using a different variable, let's call that Y. That would be the outer part of my secant AF. And I'm now going to do one of two things. I can do a secant tangent again because I actually have the length of AB. I'm going to choose to do secant secant and not use the answer that I just got. Just in case I made a mistake, I like to try to use my original numbers from the problem. So I'm actually going to use my 2 secants. I'm going to use AE and AF. So my theorem that I'm going to use here is secant secant. That's theorem 1016, similar to what we did in problem 3. So it's going to look like WOP equals WOP, whole times outer part equals whole times outer part. Left side is going to be exactly what I did up above, because I have the whole length for AE up here is my 6 plus 10, or my 16, times my outer part is 10, equals whole length for AF. Whole length is 12 plus Y, times my outer part is just the Y. Okay, so make sure you can agree with that setup. Now it's time for some algebra. So my algebra is going to give me, I'm going to run out of this wrong. 160 is equal to, let's distribute. I know this looks a little bit backwards. You can write it the other way if you want. 12y plus y squared. And now you're looking at something and saying, don't know if I like that. The algebra is fine. We do have a y squared that we have to deal with. Okay, call it x squared, whatever. We've got a variable squared, so we're looking at a quadratic equation. From here, go back to algebra. We solve a quadratic equation by setting equal to 0. I'm going to put my y squared term first, plus 12y minus 160 because I subtracted that. And now I need to be either factoring or doing quadratic formula. You know my choice. My choice is I'm going to try to factor this. And I've got 160. First thing I'm thinking is 16 and 10. That's not going to give me a 12. So let's keep going with factors of 160, dividing, and I'm getting 8 and 20 would work. 8 times 20 gives me 160, so it looks like that's going to give me a 12 if I subtract. So let's make the 20 positive and the 8 negative. Negative 8 times 20 multiplying gives me negative 160, and then adding a negative 8y plus 20y is going to give me my 12y. So there's my factors. Setting equal to 0 and solving, of course, we change the sign. So y equals 8, y equals negative 20. And in this case, geometry tells me that negative 20 is an extraneous solution. Can't have a negative length, so I am going to have a single answer of y equals 8, which was the length of AC. Not a bad idea to go back up here and double check that. If that's 8, does it work that whole times outer part equals whole times outer part? Okay, so there's your two answers for number 4. Definitely up the challenge a little bit with number 4 compared to 1, 2, and 3. One more. Let's work through number 5. So here's number 5. Go ahead and set it up. So we've got AP is 8. That'd be this part of the chord. BP is 5. So that's the other part of my chord here is 5. CD is 14. So that's a little bit hard to label there, but that's 14 is that entire length, the whole length. And we're going to try to find CP. So this is my X right here. Okay, so I'm going to my chord theorem, and if you remember, this is the one that has, let's see if I can make some room here. Not going to let me do that. I'm going to shrink this a little bit. This is my one theorem that has the P's and no W's. So I do know that part times part equals part, times part when I'm dealing with my chords, and I don't use the whole length at all. So this is going to present a little bit of a problem because for CD I know the whole length, but I don't know either part. So I'm going to have to get a little bit creative here. But let's start with the easy part. The easy part is definitely AB. I've got the two parts. So 8 times 5 is me multiplying the two parts for my length AB. And then when I get to CD, I can say that I've got X for one of my parts. So it's equal to X times something. And the question is, how do I name the other part here? This part, PD, in terms of X, without introducing a new variable. How's the 14 going to help me? And some of you are thinking about it and figuring it out already. I can hear you. I'm going to be saying that that part is 14 minus X. So if you were thinking that, excellent job. We've used that same concept when we did the angle bisector theorem with triangles. If you're thinking that, whole length minus the one part is going to give me the other part. It's an algebra problem, so 40 equals X times 14 minus X. I'm going to be distributing here, 14X minus X squared. And you're looking at a quadratic equation again, you got it. So add my X squared minus 14X plus 40 is equal to 0. I always like to keep that X squared term positive, so that's why I chose to put that on the left side. And now I'm going to look at factoring that, or you could be using quadratic formula right now. Let's see if I can factor that. X and X. I need two numbers to multiply to get 40. 10 and 4. Minus 10 minus 4. So I get X equals positive 10, X equals positive 4. Interesting. So I've got two positive answers this time. Can they both work, or do I need to throw one out? Before I had a negative, so I had to throw that out. So looking at your picture, which one would be your answer, 10 or 4? Take a minute and think about that. I'm guessing most of you are saying 10 right now because it looks like CP is longer than PD. Okay, but remember, your picture isn't necessarily to scale. Do we necessarily know that CP is actually longer than PD? And if you're questioning it, then that's a good reason that we keep both answers. So you actually do end up with two answers here. My answer would be CP equals 10 or 4. And what's going to happen is that PD is really the other part. So we're going to keep both answers there when we get 2 positive answers. Okay, excellent job. You are ready. I think we've pretty much done all of the hard cases that we could do. I think you could tackle one of these problems now. Nicely done.